Now that we have a better idea of what Go routines are, let's integrate them into our program so that we can fetch multiple URLs at the same exact time. So essentially, every single time that we call our checkLink function, we want to make sure that we spawn a brand new Go routine, which we can do by simply using the Go keyword. So I'm going to flip back over to my code editor. Inside of our main function, I'll find where we call checkLink. So right here, this function right here, we want to make sure is executed inside of a brand new Go routine. Inside that routine, we'll fetch the given link. The routine will say, oh, this looks like some blocking code. There's nothing else I can do until this function completes. The Go scheduler will detect that and then pass execution off to another Go routine until eventually everything says, okay, I've finally fetched my resources and now I'm going to print out something to the user. So all we have to do for that to happen is place the Go keyword in front of our function call. Remember, we only use the Go keyword in front of function calls. Okay, so let's save this. Honestly, that's really all we have to do to make this happen. So let's save this file and we're going to run it and see what happens. So I'll flip on over to my terminal and we'll do go run main go. Now I'm going to run this, and sure enough, it looks like absolutely nothing actually prints out. So our program was definitely working before, but now it's not working at all as soon as we started to introduce Go routines. And so this is the bug that I was talking about at the end of the last section. This is a bug that is very closely related to the fact that we are spawning these Go routines. So again, when we first start up our program, we get this single main Go routine. And then anytime we use that Go keyword, we are creating child routines. Now here's the thing. Here's where things start to get interesting. The main routine is the single routine inside of our program that controls when our program exits or quits. So when we first start up our program, we get this main routine created by default. So the main routine starts running. At some point in time, as we start to enter the for loop, so we can kind of imagine like maybe right here, our main routine starts to create all these child Go routines. It starts to create the child Go routines. We create like maybe 4 or 5 in total. And then after that, the main routine says, okay, is there any other code inside of this main function for me to run? Like, is there anything else for me to do? And at that point, after it finishes the for loop right here, the main routine says, oh, I guess there's nothing else. There's nothing else for me to do. So you know what? I'm all done and I'm going to exit entirely. The main routine doesn't care that all the child routines have not yet finished fetching their HTTP or the actual given links or the actual URLs that we're trying to fetch here. So even though these child routines still have some amount of work to do, the main routine says, I've got nothing else to do. I'm done. I'm out of here. I'm going to exit. And the entire program quits automatically. So clearly, this very straightforward implementation of saying, oh yeah, just go and do something inside of these other separate Go routines isn't going to quite work out for us this easily. Clearly, there's got to be some additional amount of work here. So the way we're going to do this is by using another construct in Go called channels. Channels are used to communicate in between different running Go routines. We are going to use a channel to make sure that the main routine is aware of when each of these child Go routines have completed their code. So essentially, we're going to create one channel, and that channel is going to communicate between all of these different Go routines. Now, channels are the only way that we have to communicate between Go routines. There's no other way. We only communicate using channels. So we can kind of think of a channel as being something like this. It kind of intermediates discussion or communication between all these different running routines on our local machine. You can think of the channel itself as being like text messaging or like instant messaging. So we can send some data into a channel and that will automatically get sent to any other running routine on our machine that has access to that channel. We can treat a channel just like any other value inside of Go. So we create a channel essentially in the same way that we create a struct or a slice or an int or a string. So they're actual values that we can pass around, and in this case, we'll pass around to these different Go routines. Now, the most important thing to understand about channels is that they are typed, just like every other variable. So I'm not just saying the fact that, hey, this value is of type channel. I mean to say that the information that we pass into a channel or the data that we attempt to share between these different routines must all be of the same type. So essentially, when we create a channel, we say make a channel that is meant for sharing, say, type string throughout our application. So we will make a channel of type string. Once we make a channel of type string, that means we can only send string messages through this channel to other Go routines. So we are not only limited to communicating with channels of type string, we can also create a channel that shares floats or ints or booleans or structs or whatever else. But we cannot take a channel that was made with a string and say, put some float value into it. That would result in a type error, and Go would say, hey, this channel is meant for sharing ints or floats or whatever, and you can't put this specific type inside of here. Okay, so that's a little bit on channels, but obviously it doesn't really answer how we use them to really communicate across processes. Or Go routines, excuse me. So let's take a quick pause. We'll come back to the next section. We're going to create our first channel and figure out how to use it to communicate between all of these different Go routines. So quick break, and I'll see you in the next video.